Hello, Hashima. This is lesson 107, fraction problem solving for Wednesday, April 8th. Today we're going to be reviewing the concept of area and partitioning, which is something that we did before we left school. It is a little bit tricky, so I do hope that these visuals help today. And we'll also put the visuals on the drive so that you can see. So today we're going to be able to solve area and partitioning problems involving fractions. So fact number one, this is just a basic review of area. Area is the number of square units that it takes to fill up a two-dimensional shape. So we use squares to measure area because area only has two dimensions, length and width. We do not use cubes. Cubes are used for volume because volume has three dimensions. So again, we use squares to measure how much fills up a two-dimensional flat shape. Fact number two, we can partition, which means to break apart, a unit square to show part of a part. That's where we draw lines on a square to make it fraction sized instead of whole numbers. So just a really quick concept review of how area works. This should be really familiar to you from third grade. So area is equal to length times width. So you're going to multiply the measurement on the bottom with the measurement on the side. So length times width in this case is going to be 8 times 5, which gives you an area of 40. That means if you filled up this entire square, you would get 40 square centimeters. Then if you were looking at this one, it says cut the length of the square into thirds. So along the bottom, we have a length of 1, and we're going to split it into 3 equal parts. That's why I drew 3 parts up and down. Remember, to make 3 parts, you draw 2 lines. Then the width you're going to cut in half. So this time I'm only splitting it into 2 pieces with 1 line. So it's a little bit complicated, but remember, split the length one way and the width another way. And then the third example, and just by the way on this one, if you wanted to find the area of one of these, you would do 1/3 times 1/2, which gives you just 1/6. Then if you look at the very last example, it's asking you what's the area of this one. Now here, this is in a regular shape, so we're not just going to use regular multiplication of length times width. But this technique, you can just count the squares one by one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is the area of this irregular shape. Notice I'm not using multiplication here. I'm just counting the squares one by one because it's an irregular shape. All right, now that we've had a basic review of area, let's take a look at example A. It says Hope's bedroom has tiles that are 3/4 of a foot long and 1/6 of a foot wide. What's the area in square feet of one tile? Now, if you think about it, before you even do the multiplication, you've got a fraction size length and a fraction size width. So what that means is going to be a very small area because you're doing a fraction times a fraction. So using the basic area formula, area equals length times width, you can do 3/4 times 1/6 and very quickly get that it's 3/24, which reduces down to 1/8, but 3/24 for our purposes. What I did here is drew a unit square. And in the unit square, I'm bracketing off 3/4, and then on the width here, I'm bracketing off 1/6. This is to show you the dimensions of a rectangle that's 3/4 by 1/6. So notice I colored in 3 of them because that's how many are bracketed by both the 3/4 and the 1/6. I know this is a little tricky. So we've got 3 total squares colored in out of 24 colored squares, or total squares, sorry. And that's why the answer is 3/24. This is what we did with those colored pencils a couple months ago, where you shade in 3/4 going this way and 1/6 going this way, and you see where they overlap. And here I've just shaded where they overlap. And I know they overlap because they're bracketed by both of these. So 3/4 by 1/6. And again, the answer is 3/24, which can reduce down to 1/8. Let's take a look at one more example together. This time, Ruby biked a trail that is 3/5 of a mile long. After biking a fourth of the trail, she stops to rest. So we're going to use a unit square to show what fraction of a mile she rode her bike before she stopped to rest. So again, the trail was less than a mile, and then she only biked part of it. So it's part of a part. So this is actually a really small length that she rode because she did not ride the entire trail. So using the basic formula, of length times width, you're going to do 3/5 times 1/4, which is 3/20. To show that in a picture, you're going to divide the length into 5 parts. 1, 2, 3, 4, 5. And then you're going to divide the width into fourths. 1, 2, 3, 4. And then you bracket off 3/5 and 1/4, and then shade in the boxes that are bracketed by both 3/5 and 1/4. So in this case, it's 3/20. I know this is a little bit tricky, but just picture two colored pencils, 3/5, 1/4, and then the part that's shaded by both is these 3/20. All right? So you're going to try some by yourself, do the best that you can, and we will see you on Zoom today.